Okay, there we go. Now I'm live. Testing 1, 2, 3. Music, getting things ready. Okay. Hello. I kind of messed up. Well, what else is new, right? So, I guess I post a lot of stuff. I post a lot of shorts and videos and whatnot. And I got a comment. I got a wonderful comment from someone asking me to do long division. But that was last week, and I totally missed it. Oh man, I completely missed it, and I think they might have needed help last week with long division, and I kind of botched it by not doing that. So I'm gonna try to make up for that today. Again, it may be too late, right? Maybe after the fact, maybe the test is over. And that's the unfortunate thing, because I only kind of check comments and such infrequently, and infrequently compared to how frequently maybe I should be doing it. So yeah, I'm gonna be doing that today. Today will be a little late, but hopefully not too late, video session thing on long division. So let me do that. Bam. Alright, text is working, looking pretty good. But yeah, let me see if I can draw. I got 30 seconds. Also, I'm starting late today because I was busy panicking, trying to reset the stuff that I had, trying to apply to the comment, trying to do clipping. So yeah, just a wee bit late by 10 minutes. So, okay, it loaded. Thank goodness. Alright, so today's gonna be a bit of a special, bit late, a bit into the summer. Credit goes to Happy and Cinnamon Roll. Thank you very much for commenting on my short. I wish I could have seen it earlier, and I didn't miss it. But okay. Today I'm gonna go over long division, right? And I'm gonna try to go over what I think is the level at which they wanted it. Now, basically, long division is it's division, but longer. I know, it sounds silly, because normally when you think of division, you think of, okay, well, what's like 10 divided by 2, right? You kind of cut it in half, and then it becomes something like 5. But with long division, it's a way to actually write out the thing in... Oh, I'm missing something. I knew it. There we go. It's a way to write it out in a way that you can understand, and using pen and paper. So not like calculator, right? If you have some kind of crazy numbers, and that might be a little too hard, but for long division, it's something maybe simple like 2 divided by 10, right? Because this is basically the same thing, it's just in a different format. And the way it works is that instead of just kind of knowing offhand or memorizing, okay, so, you know, if you have 10 and it's cut in half, it's, you know, 10 is also equal to, let's see, it's equal to 5 plus 5, and there's 1, 2 5s, okay, so then it's 5, or some other way in which you do it. Long division actually kind of makes more sense than memorizing, because instead of thinking of I need to memorize these things divide into this, it would be just a simple formula that you would follow. And the formula kind of goes something like this. And I'm just going to add a little bit of extra to it. It's still 10, right? It's just 10.00, which is basically for like any number, you can just kind of add 0.0, and as long as you don't add anything to the end, it's basically the same. Right? So 1 equals 1.0 equals 1.00. Like these numbers, they usually mean nothing and people leave them out. But I'm going to include it here just so we can kind of expand a bit more on long division. Although maybe I should save this for later. Hold on. Let me save this for later. Yeah, okay. So for now, the simple way is you would kind of take the number that's on the outside and you would compare it to each digit or set of digits. I think the closest way to kind of compare it is when you do kind of addition, and it's not just you do it side to side like 5 plus 10. Oh no, wait, hold on. What's a better way? Minusing, yeah. 10 minus 5 equals 5. But you would kind of stack it like this. And again, I'm getting to the long division. I just kind of want to bring back a previous example where maybe you would have something off to the side like this, right? But then there could also be like a formula for something like this. So what if it's actually let's go 1, 2, 3. Alright, so what is 123 minus 5, right? And normally this is something you can kind of count with your fingers, right? Where you could kind of do it that way. But actually the way you would do it is you'd kind of take away a digit from the 2 in the tenths place, so then it become 1. And then you carry that over to the 3, so then it becomes 13. And the reason why you do this is because you can't really do 3 minus 5. It doesn't kind of cut into it cleanly. And if you just try to do it in that way, you'd have like negative 2. But then if you try to do it, without carrying the number over, then you'd have something weird like 100 and 20 and negative 2, and that's not quite right. So here what you do is you actually take away a digit to make this into a larger number. So it'd be 13. And then you do 13 minus 5, so then you carry the 1 down, it becomes 1. You carry the 1 down, it becomes 1. And then with the 13 minus 5, that becomes 8. And there's your answer. In a similar way, long division kind of uses this principle of carrying numbers over. So, for example, if you have 2, or 10 divided by 2, right? You would first try to divide it into 1. But then you'd think, well, 2 doesn't really divide into 1 doesn't really divide into 2. It'd become like 1/2. And then if you try to do it that way, then you might get, okay, so you get like 1/2, and then you have 0. But that's not it at all. No. We already know the answer is 5. So then we have to actually say, okay, how many times would we need to multiply 2 by to get to the number? So here we would think, okay, what's 2 times 1? That equal 2, but that's too big. So what about 2 times 0? 2 times 0 is 0. So then what we would do is, okay, 2 times 0 is 0. And so then you'd say, okay, so 1 minus 0 is 1. Okay. And then here you drag down the next digit. And the next digit would be also 0. Now here's something now we can work with, right? How many times do you need to multiply 2 to get into 10? And then knowing our kind of memorized math, then we would say, okay, well then we do 2 times 5 equals 10. So we put 5 on top because you have 2 times 5. And then you put the result of what is 2 times 5 minus 10. And that zeroes out. And then now that you have no more digits, you have no more zeros, then you kind of get your answer as technically 0, 5, but you would just probably put 5, right? Now that's kind of again, a little weird, but it kind of makes more sense when you do harder numbers. as weird as that seems. So say for example, if you have, again, the bigger the number, the more it makes sense. Because like if you have, and I'm bringing back the minusing example again. If you have something like, let's say 4, 5, 6 minus 12. Sure. When you have something like this where it's a double digit, and you're trying to minus from 12, again, you could probably just use your fingers. But then you would know that 12 doesn't really minus into 6. Actually, no, I should probably do a lower number. 4, 5, 1. Yeah. Okay. So then you take away one digit from here, right? It becomes 4, and this becomes 11, right? But you still have 11 minus 12. It doesn't quite add up. So instead of just taking one digit, you'd actually minus 2. And again, I know this is a bit of a side tangent to long division, but the idea is to kind of say that, you know, as you get with bigger numbers or more weird stuff, you just apply the same principle again, and you kind of just do more of that rather than doing something completely new. So just like over here, where we just take away one digit to make it into a larger number, instead of just taking away one digit, now we need to take away 2 digits. So instead of minusing by 1 to be 4, let's minus 2 to be 3, and this becomes 21, right? And so now that we have this kind of setup, we would still carry down the numbers 4, and this time 3, and then when you have something like a, let me check, pretty sure it's 9, yeah. When you have 21 minus 12, then that becomes 9. Because you're applying the same principle of just carrying one of their number over, so that way you kind of get a bigger number to work with. And if we just do something funky, like that probably won't work, let's say 4, 5, 1 divided by 12, right? Or, you know, let's do something a little, let's inch our way up. Instead of going into double digits, let's go into larger double digits, right? So let's try 9. So what is 451 divided by 9, right? And you can't use a calculator. So the only thing that can really save you is probably long division. And again, we would just apply the same principle that we just did. And again, it's a little funky, right? But it kind of makes sense if we... Let me sidetrack once again on this sidetrack. To do it with easier, cleaner numbers, right? If we have 111 divided by... Actually, 121 divided by... No. Let's try this. There we go. 444 divided by 4. Yeah? How many times does 4 go into 4? Well, 4 goes into 4 about 1 time. So you do a 1 right here because you're basically thinking, okay, here's 4 times 4, or 1 equals 4, right? You're trying to find what number can multiply into the outside number so you could minus something and shrink what's down here. So then you do that. 4 times 1 equals 4. And then you minus the 4s. You get 0. You bring down the next 4. You think, okay, how many times does 4 go into 4? It goes into it 1 time. So you do another minus 4. Oh, sorry. You bring down the 4. Blah, blah, blah. And then you minus another 4. Because that's where you're kind of getting this into. Because it's being multiplied by the 1. Like that. And then that zeroes out nicely. And then you get to do it again. Right? And the thing is that you'll notice that it's actually 0, 4. It's not just 4. Just like how you can kind of add a bunch of zeros to a number and it be, or point 0, and it's still the same number. 4 is equal to 0, 4 is equal to 0, 0, 4. Right? Technically, what you're also doing is you're also dragging down this 0. So you have 0, 0, 4. How many times does 4 go into 0, 0, 4? Well, it's still 4, so 1 time. Then you do minus 4, And the reason why you do minus 4 is because, again, you're multiplying the 4 by the number to figure out in what place it's in. And then that way it can kind of clear it out. And then your final answer is going to be 0, 0, 0. Another way to write this is that you have, 4, 4, 4, 4, 1, 1, 1. And then I know that sometimes when you do long division, they have remainders. Now, you could just leave it as is, right? 1, 1, 1. You're perfect. But if they want remainders, even when it doesn't make sense, then you might just put like remainder 0. Because everything kind of cleared each other out. Now, that's kind of a nice cleaner way. But let's try it with a messier version, right? Now, how many times does 9 go into 4? Well, 9 goes into 4 about 0 times. Oh, by the way, once again, as another tangent, right, before we touch this example. The reason why this works is because we could also just apply it the opposite way and try to test it out, right? What is 1, 1, 1 times 4? And that, it would be 444. I think there's a cool way to do it where you kind of, well, I mean, I guess kind of a visual way is that when you have 111 times 4, right? Because it's a small number, you can just kind of visualizing adding it. So you can have plus 111, plus 111, plus 111, right? And here, you basically have one of these guys, two of these guys, three guys, 4. Because basically multiplication is adding them all together that many times, right? And so then when you could have is what's 1 plus 1 plus 1 plus 1, it's 4, 1 plus 1 plus 1 plus 1, it's 4, 1 plus 1 plus 1 plus 1, it's 4. And yeah, the reason why you would add it just kind of like that down the line is because you want to keep ones in the ones place, tens in the tens place, hundreds in the hundreds place. Okay. So now going properly back to long division. How many times does 9 go into 4? 0 times, right? Now, just for the sake of experimentation, right? What if we just try 1? What if we just try, right? Let's just give it a shot. Well, then you'd have 4 minus 9, and then you'd have negative 5, right? And then you'd still bring down the 5, and then you have negative 55. You think, okay, well, if it's negative 55, then if I minus a number, doesn't this negative just get bigger and bigger? And you're right, because no matter what we add, it's going to be minusing, subtracting from these values. So then even if you put like, 0 or 1, again, you just get another minus 9. And then you just have this weird kind of big negative number. And then that doesn't really make sense because then you have like remainder negative, I don't know, 5, 5, 5, whatever. Let's just pretend, right? And that doesn't really make sense to have, well, you have like 101 remainder negative 5, 5, 5, and that's somehow 451 divided by 9. You get all this kind of weird stuff that happens because you're misusing the formula. So if we're using it more properly, and by the way, it's not just long division you can have this issue, right? With any kind of math, if you misuse the formula, you're gonna get some weird numbers. You'd be like, wait, this doesn't make sense. How did I try to divide this number into pieces and somehow I got like this big negative that's like bigger than the number itself? Yeah. But if you apply it properly and just say, okay, 9 goes into 4 0 times. Then we have minus 0, we have 4. And we would bring down the 5 here. So then, just like in our example how we had 0, 0, 4, now we actually have a number that's larger than 9. We have 45. And how many times does 9 go into 45? I think like 5. Doing this off the top of my head, pretty sure it's 5. And I'm very confident in that, but I'm just gonna double check because I don't want to mislead anyone by being silly. Yep, okay. And, you know, even if we were to imagine there was no 1 here, right? Like it's a pretend 1. When you have something like, if you know your times tables, right? You would know that 5 times 9 is 45. And so it kind of makes sense that you would have a 5 here, because also, let's say 9 times something equals 450. Well, if you have the 9 here, and you have 45, but you have a 0, well, then it might just be 50. And if this was a 0, then you would end up actually having 50 by doing long division. But it's not. I made it more complicated. So now we're going to have to do that. And we're just 1 off. But thankfully, the 45s do cancel out. So if you do 9 times 5, 45, and follow the formula of just, again, you're multiplying a number to figure out how can we take away from the big chunky part in the middle. And we do that again here, where we say, okay, well, what number times 9 can take away the biggest chunk that we can without going over? And it would be 45. So it cuts nice and easy. And technically there's a 0 here too. And now we bring down the 1 into the 1's place. So how many times can 9 go into 1 though? That's unfortunate. Well, 0 times. So then we do minus 0 again, and then we're left with 1. But that kind of brings out the part where there's remainders, where you could just put, okay, so my answer is, and again, you could technically have the 0 here, but usually people just erase it to have things nice and clean. 50, remainder 1. And that would be your answer to 451 divided by 9 with long division. And again, it's just kind of repeating this formula over and over and over again, right? And no matter what the number is on the left side or the right side, as long as you do the same process, it kind of works. So let's do things a little wrong. I mean, we're going to do things correctly, but it's going to look wrong. It's not going to make sense. It's going to be a little confusing. So if you say, okay, well, what is, let's say 2 divided by 3, right? Well, if you follow the process, actually, yeah, no, let's do it like this. 2 divided by 3. So if you follow the process of long division, then you'd say, okay, how many times does 3 go into 2? Well, it's still 0 times. So then you do minus 0, but then you still have the 2, and you're like, well, now what? Well, again, you do the same process. You have a number on the bottom. You don't have anything on the side to kind of do it with, so then you could just put 0 remainder 2. And there you go. Now, the way these remainders work is actually works with fractions as well, just to get a little bit more advanced, right? Because I'm going to bounce back to this. What these remainders are actually fractions. So, and cool looking ones too. So this 50, remainder 1, but because it was divided by 9, actually equals 50 and 1/9. And this, 0 remainder 2, because it was divided by 3, actually equals 2 over 3. And again, you could kind of divide that up into decimal points, and I'll get to decimal point in a bit. But first, I kind of want to do double digits first. So let's do double digits now. And then I'll start working with decimal points. And then it gets more crazy, somehow. Okay. So if you have something like 120... Whoops. Whoopsie daisy. What happened? You have something like 121 divided by 11. And again, if you know your times tables, you probably already know the answer. It's 11, right? But we have to show our work with long division. Because the thing about long division, especially if you're taking it as a class or something, unless it's multiple choice, the answer really isn't as important as showing your work. Showing your work is so much more important when it comes to math and formulas and stuff like that. So even if you get it wrong, it's just like, hey, as long as you tried and you did the process, then your teacher can kind of identify that and say, okay, well, this is what you need to work on. Although, again, if this is finals, then I think this is where they kind of grade you on and say, all right, this is your last chance. But it's okay. We're getting there. All right. And hey, again, no matter what grade you are in, no matter what you're studying, you know, if things don't work out this semester or even this year, right? Hey, there's always next semester. There's always next year. It's fine. School ends. Life goes on, and then you get a job, and then you can do a bunch of cool stuff. You can even do cool stuff in school, right? In fact, I'm trying to help understand that, you know, math can be pretty cool as well. But not like super cool like some people where they do like these weird funky formulas and crazy things with derivatives and logarithmic functions. Like, nah, I'm trying to work at my level. Or at least a level that's, you know, more fun and casual to work with, right? Okay, so now we have double digits, right? How do we do that? Well, again, just like how we would do with the other one, you kind of just take the whole chunk. You kind of take the whole chunk and you say, okay, how many times does 11, the whole thing, right? How many times does that go into just 1? Well, 0. So then you think, okay, so you do minus 0, carry down the 1, drag down the 2, and now you have another number to work with. Thankfully, this one is larger than 11, right? And in fact, I'll do another one where it's smaller. 101 divided by 11. But that's later. Okay. So thankfully, this is larger. And then you say, okay, how many times does 11 fit into 12? 1 time. And again, it doesn't have to completely take away the number. It doesn't have to perfectly zero it out. It just has to take the largest, big, juicy bite chunk possible. So, yeah. Just a large chunk. That's kind of what you want. And so we're going to do it multiplied by 1. And so then you have 12 minus 11. And then you get 1. Right? And that would maybe be remainder 1 if it was just 12. But thankfully, we're actually dividing 121. So we have an extra numbers place to drag down. It becomes 11. How many times does 11 go into 11? Oh, that's neat. 1 time. Actually, I should line it up with the number it's taken away from. So 1 time, right here. So then you do, what is 1 times 11? It's 11. It zeroes out. So then your answer to 121 divided by 11 could just be 11, or it could also be 0, 1, 1, remainder 0. It's whatever you want, right? How technical your teacher wants it, I guess. Now, what if it doesn't divide nicely, though, right? What if it's just this kind of big... look at this number. Yuck. How many times does 11 go into 101? Well, if you try to do it... oh, that looks like a scary face. Hold on. Let me make it nicer. There it is. Alright. How many times does 11 go into 1? Well, it goes into it 0 times. So then you just minus 0, drag down the 1, and then you think, okay, now we put down the 0, and it becomes 10. And how many times does 11 go into 10? Oh, it's also 0 times. Ooh. So you do minus 0, and then you do, okay, how many times does 11 go into 101? And there might be times, right? Hopefully not in the math that you're taking. Maybe they choose kind of nice numbers, but sometimes you get this weird thing where you're stuck and on the part where you just basically get the same question, right? Instead of what is 101 divided by 11? Now you're faced, okay, well, what is 101 divided by 11, right? But there is a caveat, because here they want like a complete answer, right? But for this bottom part, once you start doing long division, you don't have to have a perfect answer. You could just, again, take a big chunk, right? What is the biggest number you can think of that can kind of go into this? Well, if it's not 10, because if you think, okay, 10 times 1, 11 is basically you just kind of add a 0 at the end, so that'd be 110. So maybe just like one less, like 9. Let's give it a shot, right? 9. And again, you can kind of guess sometimes, right? Because the nice thing is if you're doing this on pencil and paper or something where it's not like a permanent surface, then you could just erase it, right? Like, what if I guessed wrong? Let me just try that. Let me try to do things wrong for you so you don't have to do it. What if I guessed 8, right? So let me do 101 minus 88. And you could probably do that with your fingers. I'm going to use a calculator because, you get 13. Right? And if this happens and you think, okay, well, I got a number that's actually big that maybe it could fit in another time, what do? Well, you just go back one step. You actually say, okay, well, I did 13, so maybe I was wrong, and let me just add one more, right? So instead of 8, let me just erase that, put 9, and just try again. That's all you got to do, right? So then instead of 11 times 8, you have 11 times 9, which is now 99. It still fits underneath it. It takes an even bigger chunk. And then you could just probably nice and easy count it with your fingers, right? You get 2. But now you're out of digits. There's nothing here left. So what do? Again, you kind of drag this up to the top, and then you put remainder 2. So that would be your answer. 101 divided by 11 is 9, remainder 2. Cool. And again, sorry if it seems silly for me to kind of do problems wrong on purpose, but I think a lot of problems when people do math is maybe when they have like a lecture or someone teaching them, they only teach them how to do it the right way. They don't show them all the ways in which it can be wrong, and which they need to be able to catch themselves and realize they might be doing a mistake. So, yeah, sometimes doing things wrong on purpose is a little bit fun, because then you actually get to learn more about how to do it correctly than if you just only to do it correctly never really learned the lesson. It's pretty neat. Alright, how am I doing on time? Oh, not much, 20 minutes. Okay. Now let's do something a little bit more complicated. And again, it's going to seem more complicated. It's going to seem more crazy, right? Maybe a little bit above and beyond of what you need. But I mean, it's basically the same principle, right? Let's do. Ooh, here's a nice ugly one. All right, 59 divided by 4,000 or 42,222. Ew. Oh, this is a huge thing. All right. Well, let's try it anyways. This is a little bit different because it's going to be beyond your times tables. So there's that. All right, I might struggle with this, but let's give it a shot. So how many times is 59, the whole chunk, all of it, fit into 4? 0. Now I'm just going to kind of skip ahead and tell you that this is going to be 0 as well. So we're going to have some kind of number here. Because 59 cannot fit into 4. 59 cannot fit into 42. Not even once. So now we're left with, by dragging these numbers down, what is 422 divided by 59? Well, I don't know for certain, but I'm gonna guess 59 is kind of close to 60, right? It's just like one off. 59 is kind of close to 60. So then, alright, and then 422 is kinda close to 420. Now, this is something I'm doing off to the side to kind of simplify it because, again, we want to get the right answer, but so that you don't get it twisted or get confused or overwhelmed by maybe the strangeness of the numbers, you can always kind of round it about, because this number up here is going to be like a guess, maybe the first couple times until we actually get the right answer, right? So, how many times can 60 go into 420, right? Well, then I could just cancel out the zeros, and then I could think to myself, okay, well, how many times can 6 go into 42? If 6 times 6 is 36, and then there's 7, maybe 7? Like, with our estimates, it would be 7, right? But for the actual numbers, I'm not sure. I really don't know. But I'm going to guess anyways. I'm going to guess 7, because that's part of the process, right? Now I could guess a little lower, I could guess a little higher, sure. But if it doesn't seem right, then I could just go back, right? Like here, I'm pretty sure it's 7, but I'm going to guess 8. Like, let's say, for example, if I thought, alright, well, what if it's 8? Well, then I got to do, okay, what's 59 times 8? Ooh, that's a bit rough, right? Maybe you might need a calculator for that one. But, again, a side trick that you could do is just take a little bit of shortcuts. What you could actually do is, instead of 59, it's 59 times 8, right, is basically the same thing as 60 times 8, and then you minus the whole thing by 8. Because you're just minusing, like, instead of like 8 plus 8 plus 8 plus 8, or sorry, instead of 8 plus 8 plus 8 plus 8 ad nauseum, 59 times, right? You 2, and then you have 59. You could just do it by 60, and then you just kind of cancel this one out. If that makes sense. I might be a little going advanced and a little too far, but a nice way to do kind of these accurate numbers is to kind of estimate the closest one, and then just chop off a little piece. So, what I'm going to do is, because this is a nice whole number, then I could do, what is 60 times 8? Well, 8 times 0 is 0, so there's going to be a 0 at the end. And 8 times 6 is, well, 8 times 5 is 40. And then I add another 8, so it's probably going to be 48. But because we're doing it times 59, not times 60, right, then I just kind of want to do this where I minus an 8. And again, same thing. Carry over, or take away 1 from the 7, or 8, to make it into 7. Make this to 10. So I got 471. So, if I were to do 59 times 8, I would get 471 on the bottom, which is wrong. It is way too big of a number, right? Thankfully, we're kind of close. Instead of that, we're going to go back to 7. And we think, okay, well, that's a little bit too high. Let's just try 7, right? And so we kind of do the same process, but just sub out the numbers. Because just like how 59 times 7, we have to figure that out, it's kind of equal to, 60 times 7 minus 7. Neat. Let's all just do that. Let's see, we got, instead of 60 times 7, what's that? It was like 420? 420? Probably. Let me just do the math real quick. Yeah. Alright, and then you do a minus 7 on top of that, and it becomes 400, and take away 1, put there, 1, 3. 413. 413 does take a huge chunk out of 422. Awesome. Perfect. Ah, that's great. And so, you know, thankfully, just like how minusing works, you cancel out the 4s. That's great. How many times does 1 go into 2? 1 time. But here's the thing. How many times does 3 go into 2, right? Doesn't quite add up. So instead, you actually have to take away 1 and make it into 12. So then you have 1 minus 1. So you got 0, 0. And then, what's 12 minus 3? I think it's 9. So you got 9. Alright. Neat. Whew. A lot of work. Halfway through. Because the nice thing is that, again, you could just keep dragging down these numbers, right? How many times does 59 go into 92? Well, 0 times. So then you just do minus 0. And then you keep dragging everything down. Right? You could drag the zeros down if you want. Like if you had like a big number remainder, sure. But we've been doing that so we don't have to necessarily. But if you really want to keep everything there, you can. If you want. Now we carry down the next 2. And now we have a big chunky number. 922. How many times does 59 go into 922? And again, just like how we did here, we kind of want to guess, right? And to make kind of an estimate or a good guess, right? We don't just want to guess random numbers. I mean, we know it's definitely somewhere between 1 and 9. Because we can't guess 10, because if it was 10, then there'd be like a 1 here and this would be 0, right? So it's some number that has to be in the single digits. Now we know that 7 is 413. We accidentally did the math where times 8 is 471. Ooh. Wait a minute. I did my numbers wrong. Okay, if anyone was paying attention, they realized that I actually was not paying attention that well. And I was horribly wrong. And that happens sometimes. Aha! See, even I make mistakes. So if anyone caught it, that's great. What I did wrong was that I accidentally didn't realize that actually 59 does go into 92. Only 1 time. But hey, that's more than enough, right? I thought that number looked a little big. Yeah. Alright, you know what? I'm going to say that I did that on purpose, and I got the wrong number, so then you know how to backtrack and fix your errors, right? If it looks too big and you're like, wait a minute, that doesn't make sense. Yeah, it's because I missed one. 59 does go into 92 1 time. And so then you do 92 minus 59, right? Now, again, you want to keep what you're doing in your long division as clean as possible. And so just like how I'm doing over here, if ever you have these other little numbers that you gotta minus or figure stuff out, just do it off to the side if you have the scratch paper. So, let's do 92 minus 59. Sweet. How many times does 9 go into 2? Not enough. So we take away 1 from the top. It becomes 8, 12. And so then we could kind of now work our way down, which is how many times does, or what is 8 minus 5? 3. What is 12 minus 9? 3. Sounds about right. So then now we have 33. There we go. Ah, that's so much better. That's so much cleaner. And then we could drag down the 2. And now we have 332 instead of that large crazy number, because we actually did the math properly this time. How much time do I have? Only 9 minutes. Ugh. Okay. So, we know it's probably not 7, because 59 times 7 would be 413. But we can estimate, right? And so just like how we did over here, once again we're going to guess. 59 is still kind of close to 60. 332 is kind of close to 330. And so then what we could do is maybe do a little shorthand division. 330 divided by 60. The zeros, they cancel out. What is 33 divided by 6? It's probably like 5. Because 6 times 5 is 30. But you're still gonna have like remainder 3. If you think of it this way, right? 33. If you do long division within your long division, right? And this is an estimated long division. But if you do 33 divided by 6, let's see, 0, 0, 33 again. And then you do 5, and then you do minus 30. And then you're left with 3. It's 5 remainder 3, right? Sorry for my poor penmanship. So if 330 divided by 60 is something like 5 remainder 3, then we could probably guess that maybe we should guess 5. And then we're probably going to have a remainder. Chances are really good. Okay. So now we do 59 times 5, right? Thankfully, I think that's a bit more easy. Because then you could just kind of break it up into 50 times 5 plus 9 times 5. And 50 times 5 is 450? Yeah. And 9 times... No, wait, I'm doing this wrong. 250. I'm getting the 9 mixed up. My apologies on that. 5 times 5 is 25. And then you just add the 0 at the end. That's all it is. 9 times 5, that's 45, right? But we have to make sure everything lines up nicely. 4, 5. And then we just kind of do the addition. Let me just scooch that out of the way. There we go. Bam. So then we have, let's say, 5, 9, 2, 295? Sure, why not? So 59 times 5 equals 295. Minus 295. Let's do the math. Let's see. The 2 is going to need 1 from here, so this becomes a 2. Becomes 12. 2 minus 9 doesn't quite work out, so we're going to take 1 from here. And this also becomes 12. So we have 2 minus 2. Sorry if it's a little small. We're going to take away, again, 1 from the tens place and 1 from the 100ths place. Sorry, 1 from the tens place to add to the ones place, and 1 from the 100ths place to add to the tens place. So then we have 2 minus 2 is 0. 12 minus 9 is about 3. And 12 minus 5 is about 7. And by about, I mean it's exactly that. And we ran out of numbers. So then what we have is remainder 37. So, although you may seem and get this big ugly number divided by another big ugly number by using estimates and by using scratch paper off to the side, long division still works. It absolutely works. It just takes a minute. And for me, I guess like 10 minutes. So hopefully you won't have too many of these on your test. But if you do, you got it. You know how to handle it. So our final answer is going to be 715 remainder 37. And again, if they want it in a fraction, then it'd be 37 over 59, right? With the 715. Something like that, right? If they want the whole thing as a singular fraction, well then weirdly enough you don't even have to do any math. It technically, right? 42,222 whoops divided by 59 is a fraction. This is a fraction. It's technically not a reduced fraction, right? When you reduce it, then you get a more simplified fraction. It becomes 715 with only the 37 still over the 59. But technically this whole big thing's a fraction, so there's that. I don't know, could have just been a trick question where they say, okay, we'll make this into a fraction, and there it is. The question is the answer. That's why it's very important to read, because sometimes you might get one of these. Alright. What's next? So that's long division by 2-digit divisors. Now, another thing is that technically for long division, you can keep on going. And the way you get a decimal point answer is by keeping on going. So I'm going to go back to our example here, right? Let's say, for example, if we have this thing, and they don't want remainders, they want decimal points. Then to solve that, you would just keep dividing. And in my way early example, where I said 1 equals 1.0 equals 1.000, the way you would do that if you want to get a decimal point answer without a remainder is you just keep adding decimal points to the number in the box. Because 101 101 also equals 101.000, etc., right? Into infinity with a bunch of zeros. So, if you want to keep going, then you just do a point, add a 0. But here's the tricky thing. You have to make sure you have a point on the top, too. Because if you have a point on the top, then that kind of... everything has to kind of line up, right? The ones place has to line up with the here. The tens place has to line up. The hundreds place has to line up. And so does the points. And the decimals. So, now that we have an extra 0 that we just kind of magically got out of thin air, because numbers, we keep going. So instead of remainder 2, now we have this 0 to drag down. And it's 20. Now, maybe you could think, oh, what if I drag this point down with it? You actually don't. You kind of leave the points up here, because if you drag the point, then you're forever stuck with, you know, what is 11 divided by, or what is 2.0 divided by 11? What about 2.00? What about 2.00? It's still 2. You just keep repeating the same thing over and over again. So we don't drag down the decimal point, so then we have a number to work with, which would be 20. And then we could say, okay. Oh my gosh, pardon me for that. How many times does 11 go into 20? At least one time. So then we do 20 minus 11. And I'm going to kind of do this a little fast because I'm running out of time. Okay, I'm already over time, but that's okay. I started late, so I'm just going to keep going. We would get 9. And then we would just keep dragging down decimals, right? We would just keep adding zeros until it works. It may never work, right? Some of these things you could divide into infinity. So what number times 11 can go into 90 and take a big chunk? Probably 8. Because then we could get 88. That becomes 2. And I'm starting to see a pattern here, right? Where I'm pretty sure, pretty confident, if we keep going like this. Yeah, if I keep going like this, I drag down another 0, right? Then I say 1. It becomes minus 11. Then I get remainder 9. Drag down another 0. Becomes 90. Do an 8. And then I do minus 88. And I get remainder 2. And then it just keeps going forever and ever, literally into infinity, right? Like it's one of those things that doesn't divide nicely. And then you just keep getting all these things, right? And so then where do you stop? How do you stop, right? Do you just keep doing this? Is this your whole test? Is this your life now? Well, not quite. Yes, you could kind of keep going forever and ever, but there's actually a specific math notation that you could say where a number constantly repeats itself in a pattern without end. And that's just to kind of add a little line to the top of it, like a little hat. So we actually don't need to do, you know, if you have 101 divided by 11, you don't have to have, you know, what was our answer? 9? Yeah. 9.18, 18, 18, 18 for like ever, right? Dot, dot, dot. Instead of that, you can actually have 9.18, and because it keeps repeating the pattern of 1 and 8, 1 and 8, 1 and 8, you just put a hat over it. And then there you go. It's a repeating decimal point. And it just kind of repeats forever and ever and ever in that pattern. And so that's how you would get an answer without using remainders, but instead of using decimal points, you would do it like that. Now, I think even if I were to go to here, right, with the 37, it'd be the same process, right? You keep dividing until you find a pattern. If there is no pattern, then they'd have you stop where they want you to stop. If they say in the hundredths decimal place, then you'd kind of go into like here, 181, and then that'd be your answer, right? If they said in the, let's see, the ones, tens, hundreds, if they said the thousands, it'd be like this. Whatever the answer is, right? Now I understand that maybe remainders is a little bit of a lower grade stuff, and now they want you to have like decimal points with the longer division and the higher grade stuff. So you just kind of follow the instructions. Chances are they might say, okay, in the tens place, then you just put 9.18. That'd be your answer. You can keep going if you want, but just stop where they want you to stop. Alright, and so that is my lesson on long division. To anyone who might have seen it, again, sorry for a bit of the whiplash to kind of go back to math, but this was by request. Of course, I will always take requests on math that is not derivatives. I mean, I will do derivatives if you need me to, absolutely, for sure. Just please don't. I'm kidding. I'm kidding. And again, credit goes to Happy and Cinnamon Roll who requested long division lessons. I hope this kind of was a bit of a comprehensive overview on just not to show you this is how you do it right, but also if you do things wrong, this is how you catch yourself and correct it. As well as kind of learn some new stuff. Like how to be cheeky and say, yeah, this is technically a fraction. That's the question. But also how to, you know, keep going and adding decimal points so that you could go into a more accurate answer. Alright, so yeah, again, anyone here that's here, thank you for coming by. Always appreciate it. And I hope you have a good night. And take care.